Hello, we are still explaining the safety analysis procedure. Last time we explained the steps related to hazard identification, analysis, and evaluation. Today we will begin with the hazard controls and the rest of the following steps. Usually, in any workplace, most of the hazards can be identified. After we do the identifications, we should try to remove these hazards. If we were not able to remove the hazard entirely, we should try to control it. The controls will not change the severity of the hazard, but will change the likelihood. The number of times this hazard might cause an accident will be minimized, will be under control. Now, some of the hazards may only be controlled because these hazards cannot be eliminated entirely from the system, such as hazards caused by electricity. So we can only control it by using barriers and circuit breakers and signs and so on. So we can say that the purpose of controls is to isolate people from the hazard. And we have two types of controls. We have the engineering controls and the management or administrative controls. Now, with the engineering controls, we make some changes to the tools and machines, equipment, in order to try to mitigate risks and, as we said, to isolate people from the hazards, such as using hoods for fume or gloves, putting some guards for rotating parts in a certain machine so that we do not accidentally touch it. So I'm isolating the workers from the risk, from the hazard, when I'm not able to entirely eliminate this hazard. Now, with management controls, the changes will be made to the organization itself, such as by developing a plant safety plan. So, how do we do this? Usually, management will hire a safety representative, will try to make some training to workers so that they will become more safety aware. Also, management will try to make regular reviews for the sites or the system and give approvals to changes and modifications so that to consider all the safety aspects to see whether we are making some modifications that might cause some harm or hazards to the system and people working in that system. Sometimes the safety plan will include that the safety engineer should sign all the changes or the drawings to make sure that everything is safe to use in that workplace. Moreover, management will provide the personal protective equipment for all the employees to ensure their safety. Now we want to talk about the hierarchy of risk control measures. When we are trying to control the risk, we have some priorities to follow. Now, our first priority or our top priority would be designing out the hazard. This means that we should try to take the hazard out of the system completely. For example, if we have some dangerous chemical material that can cause explosions, the best thing to do is to get it out of our workplace and store it in a remote place to make sure that we are getting this hazard out of the system completely. If we are not able to do that, then the second thing to do in the hierarchy of hazard reduction will be to use safety devices. We use the safety devices if we are not able to design out the hazard completely, sometimes because it's impossible, as we said, regarding hazards related to electricity, or because sometimes it's very expensive to do that. So in this case, we will use the fail-safe devices. What is the fail-safe device? It is a device or a system designed to remain safe in the event of failure. So the fail-safe isn't designed to prevent failure, but to mitigate it when it occurs. For example, the fuse in an electrical cable, the fuse would burn to protect the electrical device, or the mechanism in the lift elevator so they don't drop if the cable breaks. The elevator will not drop completely in that case. So these are the fail-safe devices so that they will allow us to remain safe when the event of failure occurs. Now, if we were not able to do the preceding steps, at least we should warn operators of the imminent danger. You have to tell the workers that there is a danger approaching. For example, when we use gas detectors or smoke detectors, if we see that the detector is working and producing the horn or the red light, then this is a warning to people working that the danger is imminent, and you should start following the escape plan or leaving the place immediately, or evacuate entirely the area. Now, if the warning devices are not enough to control the hazard, then there should be some training and special procedures to follow. For example, usually in any workplace, some drills or safety drills are done on a regular basis. So in that case, they are training employees that when the danger really occurs, then you are prepared to how to deal with it. You already know the escape routes, what to do in cases of emergency. So they actually train their employees regularly to do that. They will do drills and test what would employees would really do in case some emergency occurs. So when they do this frequently, they are actually testing the procedures followed. Was it effective? Did it work? Were all employees were able to evacuate the place safely? And so on. So if we would like to summarize the risk control measures and what can be done to control risk in the workplace, the measures that are most preferred are the following. Then as we go down, these would be the measures that are the least preferred. So the most preferred measure is elimination or designing out the hazard. Substitution, substituting the hazardous substance or the process with a less hazardous one, using the engineering controls, the administrative controls, and getting and using the personal protective equipment, and providing some safe work procedures. So the hierarchy of risk control measures will look like this. This is the hierarchy, and this is the most preferred measure, and it's the most effective one. Elimination, then comes substitution, then the engineering controls and administrative controls, and the last one is the personal protective equipment. So this means that we shouldn't rely on personal protective equipment and say that this is how we are trying to control the risk. We should try from the measures found at the top of this hierarchy and then go down because these are the least effective. Let's explore more examples about different control measures. Regarding elimination, for example, we can chamfer sharp edges or remove protrusions. So when we do this, we are eliminating the hazard itself and eliminating a risk to take place. In substitution, we can replace noisy machines with more quiet machines. So we are substituting the sources of hazards, or replace chemical X with a safer chemical Y. As for the engineering controls, we can, for example, cover extreme temperature surfaces with insulation. So we are isolating people from this hazard, or use a forklift alert system. When the forklift is moving, it will produce some sounds to alert people that the forklift is on the move. We can also install guards. Regarding administrative controls, we can get or select more aware staff for the job, or select those with experience or who are highly trained. So the selection of the employees, this process itself can help control the hazards. Or for example, segregate the path for pedestrian and the forklift. We will have separate paths so that to avoid pedestrians getting hurt by, let's say, rotating and moving machines and so on. Regarding the PPEs, we have a set and a long list of personal protective equipment that can be used, such as helmets, masks, goggles, earplugs, gloves, knee and elbow pads, boots, anti-slippery boots, or boots that have a steel front to cover the toes, so that if any heavy subject falls on the feet, it won't break the toes, and so on. So these are several examples just to look at. This is as well a figure just to show you how would engineering controls look like. For example, here, if you look at this machine, you can see that some small debris might be falling away from the machine. So when we place a safety glass here, we can prevent those debris from entering our eyes, for example. So this is considered as a guard. Here as well, this is a hood with sound absorbing material to avoid or minimize noise, which is considered also as a hazard. For the vibration, we can install some springs that would isolate these vibrations. Here on the other side, you can see that this blade might hurt this worker's fingers, because he has to touch or keep his hand on the table. So when placing this transparent guard, he will protect his fingers, and as well, since it's transparent, so he will have a good visual while working on this device. Also, we have the goggles. He's wearing the goggles and he's having proper lighting. So these are guards that can be used in order to help us and help people who are working to become more isolated from the different sources of hazards. So the next step in the safety analysis process after installing the controls, the next step would be the inspection, because we need to verify that the controls are actually working and controlling the hazard or mitigating it. And this is done through inspection to make sure that everything is in place and the controls are working. So that's why a regular inspection has to be made to verify that these control measures are effective and working as required. The next step would be to accept the risk or not. Now, after we have studied the system, identified the hazards, and analyzed these hazards, done the evaluation, now it's the management turn to make formal decisions about the risks that are considered accepted and the risks that are not accepted. That's why a cost-benefit analysis has to be done, because this analysis will help management take the proper decision regarding the different risks included at the workplace. And of course, cost is very crucial in this step, because if the attempt to control this risk, a certain risk, is very, very expensive, then management would have to accept it as it is. If the risk is not acceptable, then the system must be modified again, and the hazard identification process must be followed once again. If the risk is acceptable, then good documentation should take place, because we need to write down what's the reason behind accepting this risk, so that the management can protect itself against liability claims. Now, how would management take a decision regarding whether a risk is accepted or not? Of course, we have to take into consideration the likelihood and the consequences. If the likelihood is low and the consequences are low, then this is an acceptable risk. If the consequences are high, however, the likelihood is low, then this risk will be conditionally accepted. However, if the consequences are high and the likelihood is high as well, then this is a non-acceptable risk, and an action must be taken as soon as possible. Let's see here, for example, you see this man can see that there is a risk in front of him. Okay, so there is a high probability that he would trip, but the impact will be low. So when we have high probability of occurrence, okay, or when the likelihood is high, but the consequences is low, then this risk is acceptable. Here in this case, we have low probability and low impact, so the consequence is low as well. Then this is also acceptable. But when you see here that we have low probability or low likelihood, but we have a very high impact, then this is conditionally acceptable risk. On the last or the worst case is that when we have a high probability and very high impact or consequence, then here it is not acceptable and we must take an action immediately. The next step would be risk documentation. A risk assessment record has to be kept for at least 3 years, or as long as the process or activity is still valid. This means that if you're working on a product and this product life cycle is not ended, we are still manufacturing and working with this product. So the risk assessment control has to be kept until this product is stopped being manufactured. This is an example of the risk assessment template. In this template, you can see that we need to write the department, location, when was the last date that we made the review, what's the name of the experiment, person in charge, people involved, when would be the next assessment. You'll have to write down the tasks, the hazards identified regarding these tasks, what would be the possible consequences, what are the controls used, if any, and then we will have to write down the severity, the likelihood, and what would be the risk score, so that we might advise that we need some additional controls, and action has to be done by the specific person by a certain deadline. So here we see the hazard identification and the risk evaluation and control in this template. Of course, we have to write the name of the person who has conducted this, and it has to be approved, as we said, by the safety engineer, whose signature has to be present here. The last step in the process would be the implementation and review, which should be done regularly by management. Usually, the review on risk assessment has to be carried on the following basis: at least once every 3 years, after an accident or an incident occurrence, whenever we make some changes in the processes or activities. So now you can see that the system safety process is a closed loop system. This means that engineering and management should periodically review the following: the safety program, the processes, the management organizations, and the product field use. So this is the loop that begins with identification, going to analysis, evaluation, controls, then verify these controls. We do here the risk management and decide. Management would decide, is the risk acceptable? If yes, then we will go for documentations to specify the reasons behind accepting this risk. If not, if the risk is not accepted, then we'll have to modify the system again and go through these steps again once more. And finally, we'll have to do the system review that has to be done on regular basis. So this chart summarizes everything we talked about regarding safety analysis. Thank you.